Hi, my name is Andrew Shumley, and this is Lab 2 for Physics 2. In this lab, we had a meter stick, a bar magnet, and our phone. We would line up our phone in order to see on um, uh, our phones had apps to detect magnet fields, and we would line it up so our X field would be 0, and we line the ruler up perpendicular to the phone and then place the magnet at the end of it. This was to cancel out the effect that it would have on our data being collected with by having no impact from the Earth's magnetic field. Um, we would measure the strength. Well, we would measure the distance of certain strengths of the field um, to get some average values of what distance equals what strength. And we plot this data in order to be able to create a model to find the field at 45 degrees. This is our data, and this is our n that we got. It was negative 2.638, which is good because it was supposed to be a negative number as it decreases over distance. So as you can see, the further you get away, the less field there is, and it drops off exponentially. Or guess it's technically quadratically. Um, here is our field from I'm pretty sure it was 20 micro Teslas. Um, and same thing uh, down here, 70 is at 120, 170, and this one is at 220. And these are our distances. You're in meters. Our distance perpendicular when we went to off axis was or 0.08 meters or 8 centimeters. Our predictions from the coding. Our coding we needed to get our create a function in order to find what the value of what the strength was of the field at the point. And by doing that, we were able to get that 8 centimeters away on the perpendicular axis, 45, which is 45 degrees from the magnet. It was 4 times 10 to negative 5, and then in the x direction, 1 times 10 to negative 4 in the y direction. This data makes sense, although it's not the same as what we got as right here. It was 60. This is not scaled correctly, but the value was 6 and 5 and 6 at the start. This was all 8s at the start. So these were much less, or a bit less than these values by, say, 20. But using that same scale, these are off by about 60. But they are pretty accurate. They're both positive direction, which is exactly what it should be, which is good. In conclusion, they're a bit off, but the pattern was the same. Z was 0 in both, or 0 in the predicted, very little in the observed. It was about 3 or 2. X component was smaller than the Y component. There were some errors. Phone these days do tend to have magnets, which I think were not taken into account when making this. What if we oriented the setup to not compensate for magnetic north? It would show kind of similar results. However, there would be some type of shift in the data because in one direction there is more there is more of a pull towards the x direction than in other directions. Um, what if two identical magnets were put together? It wouldn't really change what it would look like. It would just make the field much stronger. Not exactly by 2 times because the distance will change to a little bit further away. But yeah, it shouldn't change too much.